Okay, Assalamualaikum guys. Today we will present about the plant nutrition and soil. Okay. Okay, first learning outcomes. The first learning outcome that we can get is identify the macronutrients and micronutrients the plants require. Second one is describe how and why mineral ions enter a plant through root. And the last one is explain a simplified soil profile. Then, essential nutrients for plants. First, a nutrient is essential if it has an identifiable role. Second, another nutrient cannot substitute for it and fulfill the same role. And the last one is a deficiency of the nutrient causes a plant to die. Then, the beneficial nutrients. The beneficial nutrients are another category of elements taken up by plants. It is also required plants grow or enhance the growth of particular plants. For example, the first example is horsetails require silicon as a mineral nutrient. Second example is sugar beets show enhanced growth with presence of sodium. And the last one is in soybean, when root nodules are present, nickel is a beneficial mineral nutrient. We go to the next slide, which is determination of essential nutrients. Okay. Hydroponic allows plants to grow well if they are supplied with all nutrients they need. This is the diagram of hydroponic. Okay. In order to test specific nutrient deficiencies, we must omit particular nutrient in the medium and then observe the growth of the plant. If the plant's growth suffers, it shows the nutrient is essential to the plant. The soil formation. Soil is created when the rock is withered, which is breakdown. There is three types of weathering, which is mechanical weathering, which is the force of wind, rain, and the freeze-thaw cycle of ice, and grinding of rock on rock by the action of glaciers or river flow. Second is chemical weathering, which is acid rain, the formation of iron oxide, or degradation by lichens and mosses. And the last one is organism play a key role, which is lichen, mosses, and humus play the key role. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh and hi everyone. So my name is Muhammad Fikri bin Muhammad. My matrix number AS11028. So I would like to continue the presentation for our topic, which is my part is the nutritional function of the soil. So before that, I want to give you a statement, which is in good agricultural soil, mineral particles, organic matter and living organisms come together in such a way that there are spaces for air and water. So basically the statement said that if we want to have a good soil, we must have mineral particles, organic matter and living organism. So these three things we must have in the soil. And also actually it is important to have space for air and water. Because of what? The plant need water and oxygen to take up. So that's why we need the space. Okay. So now moving to the second point, it is good if the soil have different sizes because the air space will present and the roots will take up oxygen from it. So as I said before, the plant need oxygen and water. So in the way we want to make a air space, we must have a different size in the soil. So that's why if the soil have different sizes, the air space will present and it will provide oxygen for the plant. Okay. So next, now we move on to the next point, which is the humus. So actually, humus located at the top layer of the soil. Okay. So humus, which mix with the top layer of the soil particle, increase the benefit of soil. So why I say that the humus will increase the benefit? Because firstly, it will cause the soil to have a loose, crumbly texture that allow water to soak in. As we know, plant need water. Okay, water is one of the substance that is important for plant. So that's why it is good to have humus. So next, after rain, humus decrease the chance of runoff. Okay, So after rain, humus which will decrease the chance of runoff, which is bad for plant. So next, the third one, it helps aerate the soil by swells when absorb water and shrink when it dries. So basically, the third one is the humus will swell when it absorb water and it will shrink when it dry. So with both of the action, which is shrink and swell, the humus will help to aerate the soil by two action, which is swell and shrink. Okay, so I hope you understand. So the fourth one, it is good when the soil to contain 10 to 20% of humus. So if you want to have a good soil, we must contain between 10 to 20% of humus. And next, it is acidic, so it retains the positively charged mineral. So basically, after this, I will explain to you about the cation exchange. Okay, so after this, you will more understand about this point. Okay, lastly, organic matter in humus broken down by bacteria and fungi is returned to the plant. Okay, for your information, in humus there is organic matter. So the bacteria and fungi will break down that organic matter and it will return to the plant, which is, yeah, it will give the plant benefits. So that's why will with all the plot, sorry, with all the points that I explained, it is proven that humus is benefits to the soil. It will give more benefit to the soil. So that's all from this slide. Thank you. So moving to the next slide. Okay, so the next slide, I will explain to you about soil particles. So the soils are a mixture of three types of particles, and also which is sand, silt, and clay. So there is some information about these three types. Firstly, sand. The size of sand is between 0.05 to 2.0 millimeter in diameter, which is the largest, and water drains readily between the sand particles because it have many large particles that make larger space. So the water will drain faster in sands because it have many large space. Okay, so the second one is silt. The size of silt is 0.02 to 0.05 millimeter in diameter. So lastly is clay. So the size of clay is less than 0.002 millimeter in diameter, which is the smallest. And also it consists of small spaces that fill with water. So it is good for plant because it contains water. So next point, the ideal soil is called loam soil, which combine aeration of sand and mineral retention of silt and clay. So if you want to do gardening, farming, so I suggest you that you might choose the loam soil because it is good for plant. So the next one, clay and humus are negatively charged that will bind to positively charged minerals to prevent it from washed away by leaching. So the last point, cation exchange is a process that hydrogen and other positive ion exchange place with positively charged minerals and root takes up needed mineral nutrient. Okay, so for better understanding, I want all of you to focus on the picture. Okay, picture. So as I said before, the clay and humus, which is the soil particle, they are negatively charged. Okay, so the mineral nutrient which the positively mineral nutrient like calcium, potassium and magnesium, they will bind to the soil particle, and after that in the root they have hydrogen, which is a positively charged ion. So the hydrogen will exchange with the positively charged mineral to for the plants to take up the positively charged mineral. Okay, as you can see, the hydrogen will go to the soil particle. Okay, will bind to the soil particle because it is negatively charged, and the calcium will taken up by the roots because there is cation exchange. So this mechanism is called cation exchange. Okay, so in simple sentence, the hydrogen from the plant will bind to the soil particle, and the positively mineral at soil particle will go to the root, will taken up by the root. Okay, so that's why cation exchange is important for the plant to obtain mineral nutrients that is positively charged. Okay, so that's all from this slide. So move on to the next slide. So now I will explain to you about the living organism. So there is 5 living organism that will help to increase the quality of the soil. Okay, so now let we start with the first one, which is the small plants. So the small plants will help to form soil from bare rock. Okay, and the second one, the large plant. So the roots of larger plant will penetrate soil even to the bedrock layer that will open up soil layer. So the larger plant, the roots of larger plant will penetrate to the lowest level of the soil, which is the bedrock, and will open up the soil layer, so it can allow water, air, and animal to follow the soil layer. Okay, so there is good for soil. So the next one, which is the third one, soil dwelling animal. So this animal will disturb and mix soil by borrowing it. So which means they will make a hole in the soil. Okay, so for example is the snakes, moles, and rabbit. So this is the mole. Okay, so the fourth one, the smaller animal. So the smaller animals like earthworm, they will ingest fine soil particles and deposit them on the surface as the worm cast. Okay. So the second point, the earthworm also will loosen and aerate the soil. So this action will help to increase the quality of the soil. Okay. So the last organism, which is the microorganism. So microorganism responsible for the final decomposition of organic remains in humus to inorganic nutrients. So as I explained before, the microorganism will responsible for the decomposition of organic remains in humus to inorganic nutrients, okay, which is important for the plant. So that's how microorganisms help to increase the quality of the soil. So that's all 5 living organisms that I would like to explain to all of you. So I hope all of you understand the role of each of these living organisms. Okay, so thank you.
Assalamualaikum and a very good day. My name is Muhammad Hazli bin Muhammad Fauzi, AS10940. Today I'm going to continue the presentation of plant nutrition and soil. Just now, Mikael and Fikri already did their part, already presented their part for the presentation, and we will be moving on to soil profile and soil erosion. Okay, first thing first, soil profile. Soil profile is a vertical section from the ground surface to the unaltered rock below. Soil profile had parallel layers known as soil horizon. Okay, measured soil will generally consist of 3 horizons, which is A. Topsoil, B. Subsoil, and also C. Perimeterial. The topsoil will be consisting litter and humus. You can refer to the diagram. B. Subsoil will be containing inorganic nutrients. C. Perimeterial will be containing weathered rock. Because the perimeterial rock and climate differ in various parts of the biosphere, the soil profile varies according to the particular ecosystem. You can see that in an example I will be taking grassland. Grassland will be having deep A horizon built up from decaying grass over many years. However, because of limited rain, little leaching into horizon B, which contains subsoil, has occurred. Next, we will be moving on to soil erosion. Soil erosion occurs when water or wind carries soil away to a new location. Topsoil is difficult to replace, but erosion removes it faster than ever before. To summarize, we can say that erosion removes the A horizon, the topsoil. At least 40% of the world's farmland is seriously degraded annually. Farmland erosion can be reduced by practices that are aimed at increasing soil organic matter. For example, crop rotation, reduced tillage, and companion crops. As you can see, this is an example of soil erosion from the diagram provided based on the slide. Next, we will move to coastal erosion. Coastal erosion, as you can see here, It is often a dramatic result of hurricane and storm surges. In an example, in California, coastal erosion has reshaped landscapes. In order for us to reduce coastal erosion from happening frequently, we need to plant as many trees as we can, because trees are critical for trees are crucial for prevention of coastal erosion. Trees does not only hold soil in place, but also break the wave from storm surges and absorb their energy. Okay, that's all from us. I would like to say thank you for watching, and may the knowledge that we gain will be useful together in the future. Thank you.